I can organize data in tables and solve problems by using the strategy make a table. The first thing we have to ask ourselves is, what is data? Well, data is any information that is collected about people or things. So let's say you ask all of your classmates what sport they play. And let's say you collect all of that information. That would be data. Another example is if you ask all of your classmates what their favorite animal is. All that information you collect, that would be data. So data is information collected about people or things. Let's look at this following problem. The students in Alice's class voted for their favorite ice cream flavor. They organized the data in this tally table. How many more students chose chocolate than strawberry? So, of course, first thing we need to figure out is what exactly are they asking us? Well, here is the question right here. And we can reread that to make sure that we understand what it is we have to answer. So the question reads, how many more students chose chocolate than strawberry? So we need to figure out the difference between the students who chose chocolate and the students who chose strawberry. And we could find out the answer to that by looking at our tally table. Now remember, data is the information collected about people or things. The one that we are most concerned about is one, chocolate, and the other one, strawberry. And that's how we're going to find the information. Now let's take a look at the tally table. Now, a tally table can also be called a tally chart. Looking at this tally table, what you need to understand is that one tally mark, meaning one of these lines, represents 1. If you see a bundle like this with a diagonal, that represents 5. Let's reread the problem. The students in Alice's class voted for their favorite ice cream flavor. They organized the data in this tally table. How many more students chose chocolate than strawberry? So making this table is a way to organize the data, and it's a strategy that can be used to solve problems. What other way do you think we can show the data to better help us solve the problem? Well, here is the tallies. What we can do is use numbers instead of tally marks. So in other words, for vanilla, how many tallies were for vanilla? Well, we have 5 here, 6, 7. So we can simply write 7 to show that the tallies equal 7. We can also record it in another table. So for vanilla, we know that it's 7. How about for chocolate? Well, let's look at that. Let's look at the tallies. This is 5, 6, 7, 8. So 8 people chose chocolate as their favorite. And we could simply fill that in our chart below. And the last one, strawberry. Next to strawberry, there are 1, 2, 3, 4 tallies. So down here, what we did was we created a frequency table. Now the word frequency means how often something occurs. So how does this frequency table show how many students chose chocolate? Well, it shows it with the number 8. How does the frequency table show how many students chose strawberry? Well, that's done with the number 4. Now let's look back at the question we have to answer. How many more students chose chocolate than strawberry? Now you know that's not a joining problem. That's actually a comparing or a comparison. We're comparing chocolate to strawberry, or rather, how many students chose chocolate than strawberry. So you know that we would have to subtract to find the difference. So how would these numbers help us find how many more students chose chocolate than strawberry? We would simply use the numbers to subtract. And those numbers would be, well, 8 students chose chocolate as their favorite, and 4 students chose strawberry as their favorite. And the difference between 8 and 4 equals 4. So how many more students chose chocolate than strawberry? 4 more students chose chocolate than strawberry. Now think, does that answer make sense? Is it reasonable? Yes, because 4 more than 4 strawberry is equal to 8. Let's try another problem. It reads, how many fewer bean plants were 9 inches tall than 7 and 8 inches combined? So there are a few things here. We need to figure out how many fewer bean plants were 9 inches tall than 7 and 8 inches combined. So we need to figure out how many fewer bean plants were 9 inches tall than 7 and 8 inches combined. So what information do we need to use? Well, all the information is right here. The data in this tally table is going to tell us about the bean plant heights. Now, how can we use this information? Well, here are tally marks. We can simply take the tally marks and put the data in a frequency table. So let's do that first. So if we fill out the frequency table, we know that the title is bean plant heights. And we took that right off of the tally table. We need to fill in the columns as well. Height in inches, but instead of tally, we're going to name this column number, since we're making a frequency table. So the height in inches, we can also get that straight off our tally table. That would be 7, 8, 9, 10. So let's go ahead and look at our tallies so we can continue constructing the frequency table. So height in inches, 7 inches. Tally marks would be 5, 6, 7, 8, 9. For 8 inches, that would be 5, 6, 7, 8. For the height in inches that are 9, that would be 5, 10, 11, 12. And for the bean plants that were 10 inches, that would be 5, 6, 7, 8, 9. So far we made a frequency table to organize the data. Now we can use the numbers to add the number of 7 and 8-inch plants together, since it says combined. So, plants that were 7 inches. There were 9 that were 7 inches. How many plants were 8 inches tall? Looking at our frequency table, here's 8 inches and there were 8. So if we were to combine or join it together, that would be 9 plus 8. And you know that 9 plus 8 equals 17. Is that the answer? No. We just figured out how many plants were 7 inches and 8 inches combined. We still need to figure out how many fewer bean plants were 9 inches tall than these two combined. So now we need to go back into our frequency table and figure out how many plants were 9 inches tall. And looking at our frequency table, we can see that there were 12 plants that were 9 inches tall. So this is again a comparison problem. We're trying to compare plants that were 9 inches tall to that of 7 and 8 inches combined. So you know that would be a subtraction problem. So it would be 17 minus 12. And that would give us 5. So how many fewer bean plants were 9 inches tall than 7 inches and 8 inches combined? 5 fewer bean plants. So let's review what we did. What strategy did we use to solve this problem? Well, first, we made a frequency table to organize the data. Then we used the numbers to add the number of 7 and 8-inch plants together. Then we subtracted the number of 9-inch plants from the total of the 9 and 8-inch plants. Why do you think we chose this strategy? Well, we wanted to show numbers instead of tally marks because comparing numbers is easier than comparing tally marks. So here we have a tally table and here we have a frequency table. How is a frequency table different from a tally table? Well, a frequency table uses numbers to show data. A tally table uses tally marks. How is a frequency table helpful in solving problems? Well, in a frequency table, you can easily find and use the numbers in a frequency table. So, was this the only strategy we could use to solve this problem? No. There are other ways that you could have solved this problem. This is just one way. So in this lesson, you learned how to organize data in tables and solve problems by using the strategy, make a table.